This is the first of several videos outlining some of the practical issues with designing, prototyping and constructing circuits. Some of the advice here is aimed at beginners or hobbyists, but other parts at undergraduates learning to become professional electronics engineers. I want to start by discussing the design process which professional engineers go through, and then in the following videos illustrate some of these points in more details. Of course, amateurs will not go through the same rigorous process and might, for example, go straight from a paper design to a prototype circuit. The design process might be illustrated as shown in the diagram on the screen. Let's go through each of the stages one by one, assuming that the first one, capturing the concept, is fairly clear. Firstly, the designer must choose a circuit design. There are often several choices, perhaps using different types of electronic device or different topologies of circuit. We'll see some of these later in the course. Some of the important points a designer will consider at this stage are the complexity of the different options, the power supply requirements of the system, the cost, the required noise performance of the circuit, the required specification, like the gain of any amplifiers for example, the availability of components, and other issues, for example special performance requirements. Circuits might come from student notes, from textbooks, or from manufacturers' datasheets. One source of more unusual circuits in their design are the so-called circuit encyclopedias, which are collections of hundreds of circuit ideas, all put together in one large book. Two important points to bear in mind when choosing a circuit are that simple, elegant designs are often more reliable than complex ones, and this might be especially important in applications where access to the system is difficult. Secondly, the choice to use specialist components only made by a single manufacturer may cause problems in the future if these components are discontinued by that manufacturer, so sometimes it's better to use generic components. The next stage in the design process is simulation. Simulation is the use of computers to test a circuit virtually. The computer can mathematically model all the components in the circuit and produce a virtual calculated output. This allows us to see how the circuit will behave without building it. One important aspect of this is that it allows us to test the effect of variations in our components or inputs or power supplies by putting in varying values to the computer in order to see how the circuit behaves and if it is robust. One word of warning, however, is that because of the mathematical models used, some of the simulations can be inaccurate, and so it is always best to treat the results with caution. The simulator may also not be able to take into account all of the practical details and issues with a real circuit. After we have simulated a circuit, we are ready to prototype it. This is basically the building of a test circuit to see if the design works. There are various ways of doing this, and I will illustrate some of them in the following videos. This test circuit can then be thoroughly checked out and all the voltages and other parameters measured to ensure that they are what are expected or within tolerance. It can also be tested with different signals and component types and values, again to check its stability and its robustness. A second prototype is often made to test the final manufacturing layout using the design of printed circuit board which will actually be manufactured or made. Having designed, simulated and thoroughly tested our circuit, it's now ready to hand over to manufacturing for production. This is often done by handing over a complete PCB or printed circuit board design generated using a computer-aided design tool. In modern systems, this tool is often linked with a circuit simulator, so that the input schematic circuit diagram can be used to generate the PCB layout as well as simulate the circuit. What is handed over to manufacture is often in the form of electronic files, which are used to control the manufacturing machines used in the production of the circuit board. The so-called build pack, which includes all these instructions, also includes a list of components, test procedures, and any other special instructions required.